In this question, we've been told that two cyclists, A and B, are cycling along the same straight horizontal track. The cyclists are modelled as particles and the motion of the cyclist is modelled as below. We're told that at time equals 0, so at the very beginning of the journey, or the beginning of our observation, cyclist A passes through point O, the origin, with speed 2 meters per second. Cyclist A is moving in a straight line with constant acceleration 2 meters per second squared. At time t equals 2 seconds, cyclist B starts from rest at the origin. Cyclist B moves with constant acceleration 6 meters per second squared along the same straight line. Along the same straight line and in the same direction as cyclist A. At time t equals t seconds, B overtakes A, and this is at the point X. With all of that information, we've been asked to sketch on the same axes for the interval from t equals 0 to t equals t. Firstly, a velocity time graph for the motion of A, and then a velocity time graph for the motion of B. Okay, so let's start with the axes. This is a velocity time graph, so time is on the horizontal axis and velocity is on the vertical. We've been told that cyclist A passes through with a speed of 2 meters per second. So the initial velocity, 2 meters per second, and they are accelerating. 2 seconds later, cyclist B starts to move. So I'll start from 2 on the time axes. And since cyclist 2 has a higher value for acceleration, at some point they're going to match speeds, and at some point afterwards, cyclist B is moving with a higher velocity than cyclist A. We've been told that at t seconds, cyclist B overtakes A. Well, t is going to happen after they've matched velocities and cyclist B actually has a higher velocity than cyclist A. Here, they have the same velocity. It doesn't mean they're in the same place. Sometime later on, the area underneath each of these graphs is going to be equal, and that is where they're at the same place. This leads into part B, where we're asked to explain why the two graphs must cross before we get to the time t equals t. Well, that's because cyclist B needs to have a higher velocity than cyclist A to overtake or catch up. They will never catch up if they're not at some point moving at a higher velocity than cyclist A. And we know that they do more than catch up. We know that they actually overtake. So we are expecting with that constant acceleration for their velocity, for their line graph to go above the line graph for cyclist A. Part C of the question says that we should find the time when A and B are moving at the same speed. Well, we already pulled this off of the graph. We know that this is the time that I've circled in red where they're moving with the same speed. They're moving with the same velocity. So this looks like a coordinate geometry question where we're actually looking for the intersection of two straight lines. So let me form the lines that I'm going to work with. So for cyclist A, we know that y equals mx plus c. We know the coordinate of the intercept is 2, and we know that the gradient is 2. So that one was nice and easy to draw. For cyclist B, we need to use a bit more information. We do know that the gradient is going to be 6 because the acceleration was 6, but we don't know much more. I can use the one coordinate that we do know. We do know that this goes through the coordinate 2, 0. Substitute 2 for x and 0 for y to find c. Now I know the full line equation. Y equals 6x minus 12. Where do these two lines intercept? We're going to equate them and then solve to find the x value where they intercept. Rearranging, and we get x equals 3.5. Well, x is the horizontal axis, time is on the horizontal axis, so time is 3.5. So after 3.5 seconds, they will have the same velocity for a split second, and then B starts to have a higher velocity. In part D of the question, we're asked to find the distance OX. What is the distance that they travel? What is the distance that they've traveled when B overtakes A? As I said before, it's the area that's going to dictate the distance. So we need to find a value of t where these areas are the same. The two shapes I'm working with I have a trapezium, and I have a triangle. Let's put the dimensions onto the shapes. So for the trapezium, we know that the initial velocity, that will be the first height, is t, and the final velocity, the velocity later on, is going to be given to us by the function. So when the x variable is t, the height of the graph is going to be 2t plus 2. We're substituting into the x. The width of the base of this trapezium is t. Let's think of the triangle. On the triangle, the base is going to be t minus 2. Have a look at the original diagram. The distance between the initial time they started and the time we're considering is going to be t minus 2. The height is going to be 6t minus 12. We've got an expression for each of these shapes. We're now just going to write on geometry and the algebra skills we have from GCSE. For a trapezium, it's half the parallel sides added together, multiplied by the distance between them. For the triangle, it's half the base multiplied by the height. Okay, let's do some tidying up. I can add together to get 2t plus 4. I can multiply the half into the second bracket, so I get 3t minus 6. From here, I'm just going to expand and rearrange. We're generating a quadratic, that's what we want to work with, and then we can rearrange and solve. In this case, I recognize that 2 is a common factor. I can take out the 2, and actually, I can factorize this quadratic without too much trouble. So I haven't even gone to my calculator at all, just relying on my algebraic skills here. T either equals 6 or negative 1. Negative 1 wouldn't make sense in this context, so t equals 6. After 6 seconds, cyclist B has overtaken cyclist A. What is the distance that happens at? We can take any of these shapes and we should be able to substitute in to find the area which represents the distance. Let's go with the triangle. So substituting in 6, 6 minus 2 is 4, and then 6 times 6 minus 12, that gets us 24. The distance travelled is the area of this triangle. The area of this triangle is half multiplied by 4 multiplied by 24. That gets us 48 meters. The distance travelled, 48 meters. Okay, so another question where we really had to rely on a good diagram right at the very beginning, our understanding and interpretation of that diagram. And still, we needed to rely on a good diagram when we got to part D and we were thinking about the displacement, the distance travelled.